So in this video, we are going to solve problem E of recent Codeforces round 1034, that's a Div.3 round, and see how to think when a problem involves MEX. So let's read the problem statement. Define the MEX of an array to be the smallest non-negative integer not present in the array. For example, these are the examples given. We know that MEX is the smallest non-negative number present in an array. So if we have this array, then our MEX is 0 because 0 is not present. Similarly, for this, we have MEX equals to 4 because we have 0, 1, 2, 3 present and 4 is not present. So in this question, you are given an array of size n of non-negative integers, and for all the k 0 to n, count the number of possible values of MEX of a after removing exactly k values from a. So let's see with the example what this problem statement exactly tries to say. So in the first example, we have an array with 1, 0, 0, 1, 2. And the solution for this would be to print for each k from 0 to the size of the array, that is 5. We have to print what would be the unique number of MEX that we can produce if we remove k number of elements. So let's see, if we have k equals to 0, what is the unique number of MEX that we can produce? So, and the answer here would be just 1 because we are not removing any element. So the MEX of the array would be 3. And how many unique MEX did we produce? We could only produce 1. Let's see, if we could remove one element in the array, what is the total number of MEX that we can produce? If we remove this element, our MEX would be 0, 1, 2, 3. If we remove this element, then our MEX would be 0, 1, 2, 3, again 3. Similarly, if we remove this element, we would get our MEX 3, and if we remove this element, our MEX would be 3 again. But if we remove this element, that is 2, our MEX would be 0, 1, and 2 is not present, so we will have MEX 2. So how many unique number of MEX did we produce? We produced 2 unique MEX. Let's see what would be the total number of unique MEX that we could produce if we could remove 2 elements from the array. Let's say I removed these 2 elements. What would be the MEX? The MEX would be 3 because we have 0, 1, 2, and the 3 is the number that is not present. Okay, similarly, let's say I removed both the zeros. What would be the MEX of the array? The MEX would be obviously 0 because 0 is now the first non-negative integer that is not present in the array. What if I remove both the ones? What is the MEX now? The MEX would be obviously 1 because now 1 is not present. So we have 1. And what if I removed a 2 and let's say any number like 1? Then our MEX would be 2 because now we have 0 and 1, but 2 is the first non-negative integer that is not present. Can we try to make 4 as a MEX? Let's see. 2 For 4 to be the MEX, there should be at least one 3 present, and we cannot see any 3 in our array. So it is impossible for us to make 4 as a MEX. So we can't make 4 as a MEX, and similarly, any number greater than 4 cannot be made MEX. So if we tried removing 2 elements, we could produce 4 unique number of MEX in this example. And let's see, are we getting 1, 2, 4 for index 0, 1, 2, where we removed 0, 1, 2 elements respectively. And the example here, we can see we are getting 1, 2, and 4 for this example test case. So similarly, we can draw the conclusion for 3, 4, and 5 also. So let's see how we can solve this problem and try to see it in a different way. To get to a solution, we calculated MEX for each k. And let's try to think in a different way. Instead of calculating MEX for each k, let's try to calculate k for each MEX. So we have our array 1, 0, 0, 1, 2. And let's say we have the frequency of each number. We have 0, 2 number of times, 1, 2 number of times, 2, 1 number of times, and let's say 3, 4, 5 be 0 number of times. We took this till 5 because 5 is the maximum max that can be made for a size n array. Okay. Previously we saw that for each k we calculated the max. Now how can we calculate k for each max? So what can be our each max? We can have a max of 0, we have a max 1, we have a max 2, 3, 4 or 5. Now see. So let's think, what is the minimum number of k that we can use to get max equals to 0? Can we make max 0 if k is 0? The answer here is no, because we have already 0 and we won't be getting 0 as our max. Can we do that if our k value is 1? Again, the answer is no, because if we remove either of those 0, we still have 0 in our array and we can't make max equals to 0. What if k is 2? If k is 2, then yes, we can make our max equals to 0 by removing both these elements from our array. So yeah, having 2 as k, we can make max equals to 0. Can we make max equals to 0 if we have k equals to 3? The answer for that is yes. We can just remove both the zeros and then we can pick any other element and remove that. Our max would be still be 0 because there is no 0 present in our array. Similarly, we can remove 4 elements from the array and 5 elements in our array and our max still would be 0. Let's see for 1. What is the minimum number of k that should be removed from the array so that our max is 1? Can we remove can we remove 0 elements from the array and have k equals to and have max equals to 1? The answer is no. That can't happen, because if we don't remove any element from the array, our max is 3. Can we use 1k to make max equals to 1? The answer is no, because we have two 1. If we delete either one of them, the other one would just not let it happen. So can we use two deletions to make max equals to 1? And yes, we can do that. If we remove both these ones, we will get max as a 1. So 2 is the minimum number of k. Can we do that with 3 operations? The answer is yes. We can remove a 0 and or a 2, or if not this 0, we could have removed this 0. So yeah, with 3 number of deletions, we can make our max equals to 3. Oh, our max equals to 1. Can we make 4 deletions to make our max equals to 1? Let's see. We compulsorily need to make deletions for 1. We can do a deletion for 2 and a deletion for 0. And yes, our max would be 1 because there is a 0 present and 1 would be the first non-negative integer present in our array. So yeah, 4 is also possible. Now, is 5 possible? No, because if we remove all the elements of the array, our max would be 0. And therefore deleting 5 elements from the array would make our max equals to 1. Now let's see for 2. Can we remove 0 elements from the array and have max equals to 2? The answer is no, we can't do that because 3 is the max if there is no deletion. Can we make max equals to 2 if we perform one deletion? The answer is yes, we can do that, because if we remove 2, then we have 0, 1 present in our array, and 2 is the non-negative integer that is not present. So yeah, deleting one element can make our max equals to 2. Can deleting 2 elements make that? The answer again is yes, because we can delete either one of the 1 and still get a max equals to 2. And similarly, we can do that with 3 because we can delete either one of the zeros and get max equals to 3 because we have still 0 and 1 present. Is it possible to do that with k equals to 4? The answer is no, because if we delete 0, our max would be 0, and if we delete 1, our max would be 1. So yeah, there is no more case that we can use to make max equals to 2. Let's see for 3. Can we make our max 3 with 0 deletions? The answer is yes. The max of the array itself is 3. So without any deletion, we are getting a max equals to 3. Can we do that with 1 deletions? And answer again is yes, because we can remove any one of the zeros and get max equals to 3 because 0, 1, 2 is present. And for 2 deletions, we can delete a 0 and an additional 1, and we still have 0, 1, 2. So our max would be 3. Can we do 3 deletions and get a max equals to 3? Now, here it is not possible because deleting either of the elements would make that element as the max. So our case search stops here. For 4, can we make 4 as a max? Mm, The answer here is no. We can't make 4 as our max because there is no 3 present, and similarly 5 won't be our in and similarly 5 won't also be in the list. So let's see what observations can we make from this data that we calculated and try to solve this problem in the given time constraints and don't rely on brute force. So these are our max values and this is our map. So first thing that we can observe that for each k there is a range. For 0 we have a range of 2 to 5. There is no random numbers. There is a sequence 2, 3, 4, 5. For 1 we have a range 2, 3, 4. For 2 we have a range 1, 2, 3, and similarly for 3 we have a range 0, 1, 2. So for each max there is a range of k that can be used to make that max. So how can we calculate that range? A range has two values, a left value and a right value. Let's see how can we formulate using this map and this data that we calculated to calculate this left and right values in big O of 1. So for 0, what is the left value that we can observe? The left value is the minimum range. So what is the minimum k that should be removed to make max 0? That minimum k should include all the zeros. All the zeros should be removed from the array to make that array have a max equals to 0. So what is the frequency of 0 here? The frequency of 0 is 2. So minimum 2 zeros should be removed from the array to make the max of the array 0. There is one more point for this lower range that we will discuss later. So what would be the upper range for this? The upper range would be to remove all the frequencies of 0 plus remove all the frequencies of all the numbers that are greater than 0. That is, we can remove all the ones, we can remove all the twos and so on, because all the numbers greater than 0 won't become max because we don't have because we don't have 0 anymore. And also we would remove all the numbers that are smaller than our current number, leaving frequency of each number at least one so that the lower numbers don't become themselves max. So here for 0 we can observe that we can remove all the zeros and all the numbers greater than 0, that is 5. So our range for 0 becomes 2 to 5. Let's calculate this. For 1, what is the minimum number of ones that we can remove? What is the lower range? And that would be the frequency of 1 itself. The frequency of 1 is 2. So we can remove at least 2 ones from the array and have a max 1. So what would be the upper range of 1? How many maximum k's that we can remove so that our max becomes 1? And for that it would be all the ones we can remove all the frequencies of all the numbers that are greater than 1 we can remove, and all the numbers smaller than 1 we can remove, leaving one frequency for each. So leaving one frequency for 0, we will get to remove 1 0. So here the total would be 1 plus 2 plus 1, that is 4. So the range for 1 would be 4, 2 to 4. Now let's see how can we find the range for 2. To find the range of 2, what is the frequency of 2 that we can remove? That is 1. There is only one 2, we can remove that. And similarly, what's the maximum range that we can remove? We will remove 2 and all the numbers greater than 2, and for all the numbers smaller than 2 we will leave one frequency for each, and others can be removed. So one can be removed here and one can be removed here. So total frequencies that can be removed is 1 plus 1 plus the sum of this, that would be 3. Let's calculate this for 3. So what's the frequency of 3? The frequency of 3 is 0. So simply we write here 0. That we don't need to remove anything. And what is the maximum number of k's that we can remove? The maximum number of k's that we can remove is sum from here to here, and leaving one frequencies for all the numbers above that, we will get 0 from here, 1 from here, 1 from here. So total sum would be 1 plus 1, 2. Now let's see for 4 and 5. Here we can see for 4 the frequency is 0. But does that mean we can use 0 operations to get max equals to 4? The answer is no, because there is one more criteria for left range that we didn't discuss, and that criteria is that all the numbers from that current number should appear at least once. So that condition was satisfied for 0, 1, 2, 3, because these all number had all the numbers smaller than those numbers present in the array. But for the 4 we can see 3 is not present in our array. So for 4 we can simply ignore this range, and similarly for 5 we can do so. Now let's see how this data that we calculated is just simply our answer. Okay, so what will be the answer for k equals to 0? The answer for k equals to 0 would be all those places where k equals to 0 occurred. So we can see 0 occurred only for 3. So what's the frequency? 0 occurred only at one position. Let's see where did 1 occurred. We can see 1 occurred at 3 and 2. So what's the frequency for 1? We have 2. Similarly for 2 we can see 2 occurred at here, 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 here at 4 places. And where did 3 occur? 3 occurred at here, here, and here, 3 places. And similarly 4 occurred at only 2 places, and 5 occurred at one place, that is this. So is it our answer 1 2 4 3 2 1? And if we observe that, we have our answer 1 2 4 3 2 1. So then what is the need of this LR range? The need of this LR range is to calculate the frequencies effectively. If you are familiar with this range concept, it would be easier to calculate the frequency in big O of n. Let's see how we can calculate this whole data in big O of n using this. So let's say we have an array for the indices 0 to n plus 1, 0, 1, 2, 3, 4, 5, and 6. So for each lower range, we will do a plus 1 at. So initially this would be assigned at 0. So for each lower range, we will do a plus 1 And for each right range, we will do a -1 at right plus 1. So this is 5, so we will do a -1 at 6. Similarly, we have uh, L2 here, so we will do a plus 2 operation, and that would give us 2 here. And we have 4 as right, so we will do a -1 at 5. Similarly, we have 1 having a plus. Similarly, we will do a plus 1 here because of this L, and we will do a -1 at 4 because of this 3. We have a -1 here, and the 0 suggests that we will have to do a plus 1 at 0th index, and we will have to do a -1 at third index. So let's do this. Okay. Now we will calculate the prefix sum of this. The prefix sum for this would be 1, 2, 4, 3, 2, 1, 0. Now, what do you see? 1, 2, 4, 3, 2, 1. 1, 2, 4, 3, 2, 1. That is, we just calculated the frequency for each number in big O of n times. And if we did, and if we use this whole to calculate the frequency, it would have given us a time limit exceed. So yeah, this is the solution for the MEX count problem of recent Codeforces round. Let's try to code this. First, we have the test cases. We will get the test cases and our inputs. I'll get, we will get our array. Okay, so we have got our input. So if you remember in our solution, first we made a hash map. Let's make that hash map. Of int comma int empty, and for each element in our array we will store the frequency of that element. After creating the hash map, we made our ranges. Let's make our ranges. Vector of vector int ranges, and how we made those ranges. So for each max from 0 to max smaller than equals to n, because for our n size array the maximum max that we can make is n, m plus plus, we will need to find our left and right. So so let's assume our initial max was -1, and if our current max equals to previous max plus 1, that is all the previous elements are existing, then we will calculate our left and right. Otherwise we will just break off. In the case of 4 and 5, we remembered that there was no previous element existing, so we didn't calculate it for 4 and 5. So this is a check for that. If we have the current element and previous elements were existing, we will calculate our left and right. So to calculate the left, what we did was left equals to just simply map of that particular max m, and to calculate right, it would be just total number of elements minus all the elements that have previously occurred at least once. And to calculate that, we could simply just do max plus 1 here, because let's say we are here at 2 and previous max was 1, so we would just need two elements to have present in the array, that would be 0 and 1. So previous max would be stored as 1 and 1 plus 1 2. So n minus 2 elements that we could remove from our range, maximum range. Let's put these ranges in our vector left and right, and yeah, that's it. And then we can calculate our this prefix array, that would be like vector of int prefix of size n plus 1 initiated with 0 for auto e in ranges. For each ranges, what we will do is we will add prefix of left plus plus, and prefix of right would be minus minus, and after that we will do a prefix sum. For int I equals to 1, I smaller than equals to n, I plus plus, we will do a prefix sum, that is prefix of I plus equals to prefix of I minus 1. And for each k smaller than equals to n, k plus plus, we will print the prefix of k. One more thing that we added here is that if map of m exists, we will update our MEX. Use this minus sign. We need to print our ender. So yeah, 124321, 124321, and yeah, this is the working solution. Thank you.